Hello everyone. Welcome to the Chapter 5 material where here we're going to introduce, by way of especially some of these example problems from the homework, how we're going to do this material where we are solving basically algebraic equations, but we're going to call it solving business equations. In general, we're basically doing algebra here, and it does not end up being one of the main points of this class to do algebra, and so we're not going to hopefully get into too difficult of these kinds of problems, but we will see some here. So just before we get started, I want to recall this thing that's called PEMDAS, which is, do you remember what this one stands for? It is, of course, the order of operations. And we'll be using the order of operations whenever we are solving equations, and I want to explain how that's going to work. But remember the P here, it stands for parentheses. Like when you have something in parentheses, you always do it first. And then exponents come second. We're not going to be dealing with exponents too much, but I'm just putting, so here of course the y is an exponent, putting it in its place. And then multiplication, which we use a lot of symbols for multiplication. A lot of times multiplication is just if you have two numbers next to each other, it's multiplication. But I'm going to use a dot here just to avoid using an X. And then divided, of course, and we don't really see this division symbol very much either. It normally, division will just be written as a fraction like what we've been seeing before in previous sections. Then we have, of course, addition and subtraction. And so for each one of these operations, we have something that's called either the inverse operation, you could think of it that way, or else inverse, means basically like opposite. So the opposite operation for each one of these, I hope it's clear which one is which. The inverse operation for addition, of course, I'll say addition and subtraction, they're inverses. And then we have, I can try to clean up that plus, and then we have also times and divided by. These are inverse operations for each other. And that's mostly what we're going to be dealing with here. We don't have to worry about square root or any of that kind of stuff. And so what we will do whenever we're solving these equations, kind of a general strategy, I will just outline it here, solving equations, and then we will try to follow these principles all the time when we are solving these equations. And of course later we're going to start making some of our own equations that we will solve, but for this first little group here, we are simply solving some equations that are fed to us. And so solving equations, we will have kind of a first step is that we should obviously identify what we're trying to solve for. Like here it's obvious we're solving for d in this case, or z in the case of number 2, we're solving for these variables. But when we're solving equations, we should strive to basically get the variable onto one side. And so on one side of the equation, and of course here we're talking about equations, which is just a thing that has the equal sign. That's why it's called equations. It has equals, where we have two things that are here called expressions that are set equal to each other. And so these ones here, I will just use that little vocab term. These are called expressions. When you set expressions equal to each other, you get an equation. And so we're hoping to get the variable onto one side of the equation, because we might have, you see in the case of number 3, we've got v's on both sides. And so we want to get them onto the same side. And then we should collect like terms, where here like terms don't really have to worry about defining it too carefully. That's basically the terms that have the variable in there. So sometimes you might have, see, we don't just have v, it goes 14v, and then here we have 5v. Here we're going to end up having, you'll see that it is 4v. But we want to collect the like terms, and we'll talk about how to handle that one. And then we will also, after this, basically do the whole solving procedure, which I'm going to group this into just one kind of a step right here, which is to basically perform the opposite operations. I will call them this time opposite operations instead of inverse operations. Perform the opposite operation to the variable that we have being done to the variable there. And then I will also say in the opposite order. And so we will basically investigate which kind of operations are being done, which order they would be done to the variable, and then we want to reverse the order and do the opposite operation. And so I will hopefully be able to make that more clear whenever we try some examples here. But anyway, for number 1, we have obviously just d minus 36 equals 40. So the operation that's being done over here, I will write it like this just so that we can be organized. Operations done to our variable, which is called d. The operation, you see there's really only one operation that we can even list here, which is subtract 36. And so whenever we want to do the opposite operation now in the opposite order, of course there's only one operation that we have to do. So we have to do the opposite of subtracting 36. And remember, the opposite of subtracting is adding, and so we actually would like to add 36. In this case, oh, maybe I should add, in the opposite order, perform these, I should say, on both sides. Of course, we want to do the same thing to both sides of the equation, because things are equal. If you come and you do different things to both sides, then you're not dealing with an equation anymore. They will not be equal. And so we would like to add 36 to both sides. The point of adding 36 is that it undoes this subtraction of 36, so that goes away. So now our variable d, it goes 40 plus 36, which you could check is just 76. And then we could try plugging this back in for d. 76 minus 36, and in fact is 40, so it works out. Now we are trying to solve for this one, z over 3 equals 75. And so we will have here the operations that are being done to z. We have basically the operation which goes divided by 3. And that's, here it looks like a fraction, but that's really the way that we depict division in most cases, is that we draw it as a fraction like this one. And so divided by 3, now we should do the opposite operation of divided by 3, because that's the only one that's there, which is times 3. And so we would like to multiply both sides of this equation times 3. On this side, times 3 divided by 3, they would just cancel. So we have z on this side. Here goes 75 times 3, which happens to be 225. So we will go with that one. And now for number 3, we actually have quite a bit going on here. And so what we will have to do, I would like to recall, by the way, recall this kind of thing, which is called distributive property. Whenever we're dealing with these parentheses, we have to think about what happens with the distribution, because we have 4 times of this thing, v plus 25. And so there's another way of writing this, which is to distribute the 4, where it goes 4 times both of the things inside. So this would become 4 times v, which we just write 4v, plus 4 times 25, which is 100. And so we have now basically a new equation, but we just wanted to get the v out of the parentheses. It was kind of locked up in these parentheses. We don't want it in there. And so now we're going to actually have to pay attention to some of these strategies that we had. So the first thing that we want to do is get the variable onto one side. So we have 4v over here. We've got the other v's on the left side. So I would like to get the 4v onto the left side by subtracting 4v from the right side and also subtracting 4v from the left side. So on the right side, we had 4v there, but then we subtracted it away, so it's not there anymore. And so now our new equation goes 14v plus 15, and then minus 5v, and also minus 4v is just equal to 100. And now we want to do this thing where we collect the like terms. And so if we have 14 v's and we take away 5 v's, then now we have 9 v's, and then we take away 4 more, then now we will have 5 v's. Because basically what I'm doing is I'm collecting these ones, 14v minus 5v minus 4 more v. And then this will go plus 15 equals 100. And so here, this one, 14v minus 5v goes like 9v, and then 9v minus 4 more v goes 5v. So now we have 5v plus 15 equals 100. And so now I would like to do the same kind of thing where we look at which operations are being done to v. You notice that it's being multiplied by 5. It's also, we are adding 15. And so which order does it go in? Of course, based on the PIMDAS, the multiplication comes first and then it goes plus. And so we have the times 5 is the first operation. it goes times 5. I will actually use the x there just to make it more clear. It goes times 5, and then the second operation is plus 15. And so we should perform the opposite operations in the opposite order. So if we perform the opposite, it's going basically first we should subtract 15 instead of adding. And then second, we would like to, instead of times 5, we should go divided by 5. So we will on both sides subtract 15 is the first thing. It will cancel on this side. Now it goes 5v equals 85. And then we want to do the second thing, which is to divide by 5. And so times 5 divided by 5, it cancels. It goes v equals 85 divided by 5, which, if you're paying attention, it must be how much 17 looks like. And so v is going to be 17. And then we could check if we plug in 17 for v everywhere, it will end up working out. And so that is going to be how we solve the equations. We will see here, some ones where we need to make some equations. That'll be quite a bit different, and then we will make the equations and solve them. And so I hope this video was helpful for you all, and I will catch you in the next one.